We're going to start today by talking about multiplying decimals. You may have learned this in 5th grade, or this may be brand new to you. To help you remember the steps of multiplying decimals, I've came up with the phrase SMCAB. And you can see there's a picture of a cab or taxi cab to help you remember. Each letter of SMCAB stands for a step with multiplying decimals. Let's go through those now. S stands for stack. And we'll talk about what stacking is in just a moment. M stands for multiply. C stands for count. A is just and. And last but not least, B stands for bump. So SMCAB stands for stack, multiply, count, and bump. Let's go through our first example together. We'll be multiplying 4 and 5600ths times 39. You may have remembered from adding and subtracting decimals that when we add and subtract decimals, we line up our decimal points. With multiplying, we don't. We actually stack them against an invisible wall. Here's what I mean. We'll take 4 and 5600ths times 39. We're going to draw an invisible wall here, and we're going to push 39 up against the wall. So you can see that the numbers are snug tight against that wall. That's what stacking means. Okay, so we can see our decimal points aren't lined up right now. It's going to look weird. That's okay. Let's go ahead and multiply these numbers together. Remember, we start on the bottom with the ones. We're going to multiply the 9 times each value above it. 9 times 6 is 54. Put your 4 down, carry your 5. 9 times 5 is 45. Add 5 more and we get 50. Put your 0 down, carry your 5. 9 times 4 is 36. Add 5 more and we get 41. Cross off everything you're done with. Now we need to multiply the 3 and the tens times everything. But before we do that, add your 0 to mark that we're actually going to be starting in the tens down here. Okay? Oops. 3 times 6 is 18, carry your 1. 3 times 5 is 15, plus 1 more is 16, carry your 1. 3 times 4 is 12, add 1 more, and we get 13. Last step with multiplying is to add together. 4 plus 0 is 4. 8 plus 0 is 8. 6 plus 1 is 7. 4 plus 3 is 7. 1 plus nothing is 1. Okay, I know, multiplying is a long step. Next step is C for counting. We're going to be counting how many numbers there are past the decimal point in each number. In 456, we have 2 numbers past the decimal point. In 39, we have none. So, over here in our circle, we're going to write the number 2. Our last step is to bump over however many spaces we counted. So, placing our stylus at the end of our number, we're going to bump over 1, 2 places, add your decimal point. That gives us a quotient of 100, or not a quotient, excuse me, a product of 174 and 8400ths. Okay, I know that was a lot. Take a moment to digest everything, and when you're ready, turn the page. Let's try another one together. Once again, remember, when we multiply, we stack, we don't bump. So draw your invisible wall, and we're going to push our numbers against that wall. 7 and 9200ths times 5/10. Once again, it's going to look weird that our decimal points aren't lined up, but that's how it's supposed to be when you multiply. Again, start with the ones. 5 times 2 is 10, carry your 1. 5 times 9 is 45, plus 1 more is 46, carry the 4. 5 times 7 is 35, plus 4 more is 39. Cross off everything you're done with, and since we only have a 0 here in the tens, we don't have to multiply anymore. Our next step is to count how many numbers we have past the decimal point. In 7 and 9200ths, we've got 1, 2. In 5 tenths, we've got 1. That's a total of 3. Write that in your circle. Then, place your finger at the end of the number, bumping over 1, 2, 3 places. That gives us a product of 3 and 960 thousandths, or if you remember from decimals, we can actually drop off that 0, and we're left with 3 and 96 hundredths. Let's try another one. Start by drawing your invisible wall. We've got 6 times 987 thousandths. Huh, that looks weird, doesn't it? Would you like to make your life a lot easier? If so, use the commutative property to change the order of your multiplication problem. The commutative property tells us we can change the order and we still get the same answer. So we can rewrite this as 987 thousandths times 6 and make our lives a whole lot easier. Let's switch that in our problem. Draw your wall, push them up against it. Now let's go ahead and multiply. I'm just going to move the word commutative a little bit over so it's not in our way. 6 times 7 is 42, carry the 4. 6 times 8 is 48, add 4 more, we get 52. 6 times 9 is 54, add 4 more, we get 59. Okay, nothing left to multiply. Next step is to count. We've got a total of 1, 2, 3 numbers past the decimal point, none in the number 6. Place your stylus at the end of the number and bump over 1, 2, 3 places to get a product of 5 and 922 thousandths. Okay, one left to try in our notes. We've got 5 and 67 hundredths times 45 hundredths. Once again, draw your invisible wall. Push them up against it. Now you may have noticed in this case that the decimal points do line up. That's okay. If it happens when you're multiplying, there's nothing wrong with that, but we're not trying to do it on purpose. Let's go ahead and multiply. 5 times 7 is 35, carry your 3. 5 times 6 is 30, add 3 more, we get 33. 5 times 5 is 25, add 3 more, we get 28. Cross off everything you're done with and add your 0. 4 times 7 is 28, carry the 2. 4 times 6 is 24, add 2 more, we get 26, carry the 2. 4 times 5 is 20, add 2 more, we get 22. Add it together, 5 plus 0 is 5, 8 plus 3 is 11, carry the 1. 8 plus 1 plus 6 is 15, carry the 1. 2 plus 2 plus 1 is 5, 2 plus nothing is 2. Okay, deep breath. Next thing, count your total number of numbers past the decimal point. In this case, we've got a total of 4. Place your stylus at the end of the number and bump over this time 1, 2, 3, 4 total places. So we get a product of 2 and 5,515 10,000ths. That concludes our notes on multiplying decimals. Get ready for practice 1.